Hey everyone, this is Nadeem and welcome to my YouTube channel. Today we will discuss about different terminologies related to alternating current, and these are that terminologies. And as we discussed in the previous lectures about how the alternating current is generating. So this is actually the alternating current generator, and this is the coil which is present inside the magnetic field. This is the south pole of the permanent magnet, this is the north pole of the permanent magnet, and this coil is rotating inside that magnetic field, due to which the change in magnetic field will be occur. According to Faraday law of electromagnetic induction, the change in magnetic field will induce the EMF. So here is different position of that coil present inside the external magnetic field. When the position of the coil is vertical, so on the top side of this coil will have some area. The direction of that area is outward from the screen, and here the direction of external magnetic field is from the left to right. Okay, so here the angle theta is equal to 90, and we know the equation for the flux, which is equal to BA cos theta. So cos 90 is equal to 0. So here the flux becomes 0, and according to Faraday law of electromagnetic induction, if the flux becomes 0, the EMF will be 0. So here it showed the EMF 0. So this is actually the graphical representation. The y-axis is the induced EMF, and the x-axis we have the angle of rotation. So here if we rotate this coil in this way, and now it is present horizontal. Okay, so the on this side of the coil will have some area. The direction of that area is from left to right, and the direction of external magnetic field also from left to right, and here the theta is equal to 0 and cos 0 is equal to 1. Hence the magnetic flux at this position is maximum, and according to Faraday law of electromagnetic induction, the EMF will also maximum. So therefore here at angle is equal to 90, mean that at this position when the coil is horizontal, the EMF induced here is maxima. Okay, it is maximum. Okay, so here this EMF is a maximum, and similarly at this position again this coil become vertical, and here the EMF will be 0, and at this position the EMF will be maximum, but in opposite direction, because this direction, the opposite direction, is given us by the Fleming right hand rule. Okay, so here per degree change change in rotation of this coil will induce EMF, and here that induced EMF is increasing per degree. Okay, so from 0 to 90 degree, per degree rise the EMF will be increased, and here for per degree if we plot the data point, so here will be about 90 data points, okay, present, and that if we connect that data point, it will give us such like curve. Okay, and similarly from the 90 degree it will be decreasing. Okay, and at 180 it will again becomes 0. Okay, so for 90 to 180 it is not abruptly become 0, it is going towards 0 with each degree change in its rotation. Okay, so here it is increasing, for each degree it is decreasing, and it follow this shape. If we connect that data point, it give us this shape. And similarly, for in order to move from 180 to 70 degree, that alternating current is that induced EMF is also increasing, but in opposite direction, and after covering 90 steps, 90 degrees, it will reach here. And the same explanation is for this portion. Okay, so now this is called the 1 cycle. So here on the top, for if we draw the induced EMF for each degree, so here will be about 90 lines. Okay, so each line represent the induced EMF at that specific angle. I mean that if I change this angle per degree, so for each degree there will be induced EMF. So for each degree there will be induced EMF. So that induced EMF, let's say at angle is equal to 45, that will be a positive value. So here from 0 to 90 degree, for each degree the value of the EMF will be positive, and similarly that is decreasing up to here, but still that value will be positive for each degree from the 90 to 180. So here will be about 90 lines which represent the magnitude of the induced EMF, and here it will be the positive value. Okay, now according to a Fleming right hand rule, beyond this 180 degree, that there will be increase in the induced EMF, still will be the increase in the induced EMF per degree. Okay, but that increase is on the negative side. Okay, that decrease is on the negative side. So here the value of induced EMF will be negative because it is on the negative side of this 0. Okay, on the negative y-axis. Okay, and similarly here the EMF will be reducing, but still it is the negative values. Okay, so what I'm going to mention here is that one complete set of the positive values and one complete set of the negative values in the one complete cycle, in the one complete rotation is called the cycle. Cycle is actually the one complete set of the positive values, the one complete set of the negative values in one rotation is called one cycle. Now time period. Time period is the time required to complete one rotation. So for this coil, if it complete one rotation, there will be some time required. So the time in which this coil complete one rotation is called time period. Okay, time period. And now what is frequency? Frequency is actually the number of the turns, the number of the cycles, okay, or the number of the rotation per second. Okay, that how many rotation, how many times this coil is rotating inside the magnetic field per second. So here the frequency, let's say we have frequency, let's say this is the frequency, and frequency is actually the number of cycles, or number of cycles, okay, are rotations per second is called the frequency. Let's say we have to take different scenario. Let's say the first scenario is that we have this 1 second, okay, and the x-axis we have this 1 second. Okay, and here in this 1 second, okay, let's say this is the 1 second, and similarly this is the x-axis for this is also the same 1 second, and similarly we have this is the 1 second. Okay, so if one cycle. So this is the one cycle is complete in 1 second. Then and here in this case, in 1 second, if 2 cycle are completed, okay, and if at that same 1 second 3, so this is the 1, 2 and 3 cycles are completed in 1 second. So the frequency here will be one frequency in this case will be 1 hertz, okay, and in this case the number of cycle are 2 and the time is 1 second. So here the frequency become 2 hertz, okay, and at this case the time is 1 second and the number of the cycles are 3. So therefore this is become 3 hertz, okay. It means that in 1 second, if one cycle is complete, if one time the coil rotates, okay, then it will call frequency as 1 hertz. If the 2 rotation occur in the 1 second, then we call that as a 2 hertz frequency. And if 3 rotations is occur in a second, then we call that as a 3 hertz frequency, okay. So now from here the time is the same, okay. So here this one cycle complete this one for one rotation here, here for one rotation, okay, 1 second, 1 second is required, okay. Now for in this case, when the frequency is equal to 2 hertz, for one cycle here is about half second is required. So for one rotation the half second, okay, the half second is required, okay, because in 1 second there is 2 rotation. So per one rotation half second is required. In this case for one rotation, okay, for one rotation about I think so this is the 1, 2 and 3, okay, 3 let's say 1/3, I think 1/3 seconds are required, okay. So from here we conclude that if we increase the frequency, so here the frequency is less, therefore time so here the frequency is less, and if we increase the frequency to 2 hertz, 3 hertz, that time will be decreasing. So here that time is decreasing 1/3, the frequency is more. Here that is for 2, this is 1/2 second, okay. So for one frequency is equal to 1, the time is more. So if the frequency is less, from here we conclude that if the frequency is less, okay, if the frequency is lesser, the time will be more, okay, the time to complete one rotation will be more. So here the frequency has increased, the time to complete one rotation become less, okay. So this is the relation between the frequency and time period, okay. So similarly this is cycle, time period and frequency. Now what is the instantaneous value? As I have discussed here that for each degree of the rotation there will be some value, and we call that value for each instant is called the instantaneous value. So for angle is equal to 0, the EMF will be 0. For angle is equal to 1, the EMF will be 1, for angle is equal to 2, for angle is equal to 3. For each degree change, the EMF will be changed. So for each degree there will be a specific EMF value, and that specific EMF value at a specific time or at a specific degree is called the instantaneous value. Okay. Now what is the peak value here? The peak values is when, so here this is for each degree, there will be some what we can say, there will be some induced EMF. So if we increase the degree here, that induced EMF will be increased, mean that here this line, the magnitude of this line from this original, from this equilibrium position will be increasing. Okay, so if we increase the degree here up to 90, if we increase the degree, this magnitude of this line is increasing. So this line is actually the line between the instantaneous value here and this equilibrium position. So we call this as amplitude. So on the other word, we can say that for each degree rise up to 90 degree, the amplitude is increasing. So at the fixed 90 degree, the magnitude will be maximum. Okay, so here this instantaneous value at which the magnitude of this induced EMF is maximum, we call this as a peak value. Okay, so here this 90 degree is a peak value for the induced EMF. Okay, now what is the average value? So here we have that same scenario in which by each degree rise or mean that for each change change in time, there will be some instantaneous induced EMF value. So here let's say this is the first instantaneous value, this is the second, this is the third, fourth, fifth, sixth and seventh, and up to here it will become maximum. Okay, so here will be, let's say this is the 1. Here in this case this is 1 ampere, this is 2 ampere, 3 ampere, 4 ampere, 5 ampere. Okay, and here up to here it will become, let's say this is 9 ampere. Okay, now it will be decreasing. Okay, it will become from 8 to from 9 to become 8, 7 and up to 0. So at 180 degree it will become 0. Okay, and similarly in this case this is the -1, -2, -3, -4 and up to here at this maximum it will become -9, and above this the value will be here it will become let's say this is up to -9. Now it will become increasing from here. Okay, so it will be now increasing and here it will become 0. Okay, this is become -8, -7 and it will come to 0. So if we add these all values, so if we add these all values for the alternating current, so let's say I am going to add that. So here the average, we know that average is equal to, let's say here is the I1 which have 1 ampere. Okay, 1 ampere plus 2 ampere, and we will add that up to 9 ampere. Okay, and after that 9 ampere it will again going towards 0. So it is become 8 ampere, it becomes 7 ampere and it will become equal to 0. Okay, and now after that this values become negative. So here this become -1, -2, -3 and it will reach -9, and after that -9 this value become -8, -7 and it will be reach here to 0 position. Now here will about there will be large number of the values, so we will add that large number of values and we will divide that by that number. So here is let's say this is the 9 and this is 9 and this is 16 and 16, so this is about 32 values. Okay, so if we add that all values, it will give us the 0 values, the above, and that 0 divided by 32, the answer will be 0. So the average of the alternating current is 0. So in order to determine, so here why the average of this value becomes 0, because here in the alternating current the electron, let's say the electron here in the alternating in the circuit, the electron is vibrating. So here this electron is vibrating. Okay, this is, let's say, the positive x, this is the negative x. So it reach here to the positive axis, and at the same magnitude but with the opposite direction, it will come it will cover this distance in the negative x direction. So these distance will cancel each other and their average will become 0. Their average will become 0 in this case. So here from this graph we can also find that average will be 0. Okay, so this was the different terminologies related to the alternating current, and I think you got my points, and that's it guys. Thanks for watching.